G'day chemistry students, in this video we are looking at dot point 7.4.7 and in particular we are focusing on comparing different kinds of organic fuels. Let's get into it. So first off, there are many types of organic fuels that come from a bunch of different sources. Some are more renewable than others. So some examples that I've come up with is simple wood. It's been a fuel that has been used for the majority of human history. However, in more recent years, the discovery and use of a bunch of other organic fuels has completely changed our society. Coal was a big player, especially in the Industrial Revolution, still a major fuel source for society's function today. We then also have petroleum and natural gas, which are other fossil fuels that are used in different contexts. However, alcohols and biofuels are also able to be used as fuels and are used in lots of different contexts. So when comparing the effectiveness of any of these fuels, something that we need to look at is chemical viability. And this will begin to inform us of the efficiency and the effectiveness of the fuel, as well as its ability to be what would be classed as an environmentally friendly fuel. So when we are looking at efficiency, we're looking at, well, within the reaction itself, what is its energy density? How much energy can be released per gram or per mass or per volume of our fuel? And that sort of leads to this idea of how much fuel would need to be carried, especially when looking at a mobile piece of machinery that requires the fuel. Another question to ask is what byproducts are formed when the fuel is being used? What kind of environmental impact may that have? As well, are any of these byproducts cause for concern in terms of safety? Another question is, within the parameters of, say, an engine, how much energy could be released at once? So in this case, we're looking at the potential release of energy in a short burst. That may be a requirement for whatever machinery or vehicle the fuel is being used for. And can it be produced effectively? So whatever physical or chemical processes are required for production, as well as its use, can it be produced effectively? And we begin to look at those industrial processes that might be required for its production. You can also begin to look at environmental viability. The most important thing for different kinds of organic fuels is its carbon footprint. Essentially, if we are combusting an organic fuel, we're expecting the formation of carbon dioxide and a lot of it. So the first question is, in the reaction that we're undertaking, how much carbon dioxide will the fuel actually emit? And that can be based sort of against its energy density and its efficiency as well. How efficient is it? The more efficient a fuel is, the less carbon dioxide it will probably produce. We can also begin to ask the questions with using this fuel, can we reduce emissions in any way? Sort of bringing these two dot points together, the main question that we're really looking at is, from collection to production to use, can we make all of those steps essentially net zero in terms of carbon dioxide emission? If we can, or we can approach that net zero point, then we can say that potentially we might be working with an environmentally viable fuel, or at least a more environmentally viable fuel. The next question that we can ask is, are there ways in or steps in the process to ensure that we're not causing large-scale environmental damage, not just from a carbon dioxide perspective and from a greenhouse gas perspective, but also looking at any other byproducts that might be made in the production phase? Can we reduce damage or mitigate the amount of management that needs to actually occur when collecting, producing, or using the fuel? Another consideration is, how are we using land? Now, we may find that we have quite a viable option in terms of having a net zero product that is not particularly dangerous to the environment in a variety of different ways. However, it may not be particularly effective, or the fuel may have potential environmental concern if there is an overuse of land required to actually be able to collect and or produce the fuel itself. And we should always be asking the question of, are there other energy sources even outside of our organic fuels which are a lot more effective in terms of environmental viability? From an economic standpoint, what we need to consider is, how much does it cost to produce? And then also what sort of capital, resources, and other equipment apart from the organic fuel itself, which may be required for its production. Another question is If we need to try and manufacture the fuel from a bunch of different reagents or starting materials, how are they actually going to get transported to a processing facility? And then the product itself, how will that be transported for use across the globe as well? If we're looking at using a fuel that has some sort of engine or burner, how much does it cost to actually manufacture something compatible? And in a lot of cases, in terms of economic viability, new products can be a little bit more difficult to get off the ground because that may require the large-scale manufacture of new engines that are compatible with the new fuel. A lot of the time, fossil fuels that have been used for hundreds of years have historically been considered more economically viable because compatible engines have already been produced at a large scale. Another concept that we can look at is value of investment. So even if it does cost a lot of money upfront to have an organic fuel be used on a large scale, we can still look at whether or not the use of this new fuel may end up saving businesses, groups, economies over time. And then as always, we can start looking beyond our organic fuels and begin to question whether or not there are other sources of energy which may actually be more cost effective and efficient. Something that I want to acknowledge, even though I've talked about the idea of looking at fuels or energy sources that aren't organic fuels, we need to be aware that within the scope of our dot point that we are looking at for organic fuels, we're being asked to specifically compare and contrast fuels from organic sources to essentially biofuels themselves. So this dot point is less focused on looking at renewable energy sources such as wind, water, and solar, and more focusing on organic chemicals, organic fuels that can be used and trying to figure out which ones might be the most viable. So that's going to be our main focus in our lesson for this dot point. We're going to be researching some of these fuels and evaluating them against some of the metrics which have been outlined. Thank you very much, everyone. In the next video, we're going to be exploring organic chemicals which can be classified as acids and bases. But until then, have a good one.